Today we're looking at Note 7.1, Exponential Applications. So given an exponential equation in the form y equals a times b to the x, a will represent our initial amount, or in other words, starting amount. B will either represent the growth factor or the decay factor. The formula for the growth factor will be 1 plus r, and the formula for the decay factor would be 1 minus r, which brings me to r being the rate and x being time. So we will be graphing some today, but more frequently using the table. So keep in mind as we're graphing that x represents time always. When you're talking real world situation, x represents time, which also want to remind you x is the domain, and y will represent amount. So amount of whatever the problem is talking about. And keep in mind that y is the range. Okay, the amount is the range. So our first problem, $300 is invested in an account earning 5% interest compounded annually. Does this represent growth or decay? Well, when you invest money and it earns interest, that is called growth, okay? So write an equation in the form y equals a times b to the x that represents the amount in your account after x years. Well, let's go through and pick out what each of these things are. Remember, a is the initial amount. So $300 is invested. That's the initial amount. We can't find b until we know what r is, right? Because b is either 1 plus r or 1 minus r. So what's r? R is the rate. The account earns 5% interest rate. So I want to take this over here so you can see it. 5%. Where's the decimal on 5? Well, the decimal is right here. When you're talking a percentage, to get a rate, you need to move the decimal over twice to the left. So if I take that decimal and move it 2 times, the r, the rate would be 0.05. So the rate is 0.05. So then to find b, you ask yourself, am I using 1 plus r or 1 minus r? Well, since it's growth, you're going to use 1 plus r. So 1 plus 0.05 r. So 1 plus 0.05 is 1.05. Okay, so then my equation is y equals a, 300, b, 1.05, raised to the x, the amount of years. Okay, so that's my equation. This one seems to trip students up, but don't let it. What would be a reasonable domain and range for this situation? Y'all, there are going to be as many answers as there are students, okay? This is an opinion-based thing. There's no right or wrong answer unless you do something absolutely obnoxious. So let's talk. Okay, the domain always represents time. So in this situation, what are we talking about? We're talking about time is years. The years money is in an account. So obviously time can only start at 0. We can't have negative time ever. So this will always pretty much start at 0. Okay, how many years is a reasonable amount of time that I can keep money in an account? Well, the human lifespan is only, 80 years, somewhere around there? So maybe I would have money in an account for at most 80 years. Okay, now you might have said 60. You might have said 90. That's okay. All right, as long as you don't put 500, there's no way somebody can keep money in the account for 500 years. As long as you don't put something obnoxious, you're not wrong. Okay, so let's talk about the range. So the range, y, represents the amount. Okay, what are we talking about in this situation? The amount of money in your account. Well, what's the lowest amount of money you could have in your account in this situation? Well, in this situation, 300, because that's what they started with. 300 is the most. What's the max you would have if your max years is 80? Well, you need to really do the math on this then, because if the most amount of years I'm saying is 80, I need to plug in 80 for x to see what's the most amount of money I could have. So 300, 1.05 raised to the 80. So if I keep that money in the bank account for 80 years, I'll have about 14,000. Ooh, that would be nice. $14,868. And that's what I'm going to leave it at. Okay, so really, there's no right or wrong answer. A good guess is good enough. Okay, so that's that. Now let's get to the solving. Okay, how much money will be in the account after 8 years? Well, 8 represents what? 8 represents time. Okay, 8 years is time. And remember, x is time. So that means x is 8. How much money? That's the amount. That means we don't know the amount. We don't know the y. Okay, so if x is 8, what's y? You have two choices. You could either do what I just did, and in the home screen, you can take that equation and you can plug in 8 for x and find out what the y value is, or you can plug this equation into the y equals of the, where'd it go, of the table here, or of the y equals here, so 300, 1.05 raised to the x, and look at the table. So in the table, where x is 8, my y is 443.24, the same as it was when I plugged it in here, 443.24. Okay, so I personally prefer the table, but to each his own. So the question was, how much money will be in the account after 8 years? Well, when you plug in 8 for x, the y value is $443.24. So in 8 years, you'll have $443.24. Okay, so how many years will it take for the investment to double? So in this case, we don't know time. How many years? Time we don't know. Will it take for the amount to be what? So the amount of money to double, well, what did it start at? It started at 300, so doubling 300 would be 600. So when will y be 600? In this case, you don't have a choice but to use the table, because if you plug in 600 here, you can't plug this in the home screen of the calculator and expect it to solve for x for you. Okay, you can't put an equal sign into the calculator and it doesn't understand what you're saying. So in this case, we're going to have to utilize the table. I've already plugged in the equation, the original equation, into the y equals. I'm going to go to the table and I'm looking for when y is 600. So if I keep scrolling down, I know you can't see all of it. Let's see, so somewhere between 14 and 15 years, I hit 600 because it goes from 590 to 623. So I'm going to say it's going to take approximately 14.5 years, somewhere between 14 and 15, okay? So it might bother you a little, but today's not going to be an exact science. All right, let's look at number 2. So caffeine is eliminated from the bloodstream at a rate of 12% per hour. A cup of coffee has 150 milligrams of caffeine. Does this situation represent growth or decay? Well, caffeine is eliminated from the bloodstream. That means it's going away. Okay, so that's decay. It comes out of your blood. All right, so now write an equation in the form y equals a times b to the x that represents the amount of caffeine in your blood after x hours. So again, a is the initial amount. Okay, so if we're talking about drinking a cup of coffee, 150 is the initial amount of caffeine when you drink that cup of coffee. We can't find B until we find R. So what's R? R, the 12%, the rate will be, move that decimal over twice, the rate will be 0.12. So remember, B in this case will be 1 minus 0.12 because we're talking decay. So 1 minus 0.12 would be 0.88. So my equation would be y equals A, 150, times B to the x hours. So what would be a reasonable domain and range? Well, in this case, again, your guess is as good as mine. The time, well, time will always start at 0. How long do I think it will take for the caffeine to be eliminated from the blood? how many hours? Maybe 24, maybe 12 completely. It's going to take a while, right? So then my range, this one's easy. The lowest amount of caffeine I can have in my blood is 0, and the highest amount of caffeine I can have in my blood on 1 cup of coffee is 150. Okay, so the question is, how long is it going to take for the caffeine to go away? So we're going to find that out. So how much caffeine will be in the blood after 3 hours? So what does hours represent? That's time. So x equals 3, okay? What's y? What's the amount of caffeine? So again, on this one, I'm going to utilize the table. So going to y equals, plugging in 150.88 raised to the x, and then I'm going to go to my table. So the question was, how much caffeine is in my body after 3 hours? Well, in 3 hours, I still have 102.22 milligrams of caffeine left in my blood. Okay, and then the next question is, how many hours, so we don't know x, will it take for half of the caffeine to be eliminated? Well, what's half? Well, we started out with 150, so half of that is 75. So we want the amount to equal 75. So how many hours will that take for the amount to be 75? Well, let's look at the table here. So at 4 hours, we have 89, almost 90 milligrams. And at 5 hours, we have about 80 milligrams. Somewhere in between 5 and 6, I've got 80 here, 70 here. So somewhere in between here, I'm going to have 75. So I'm going to say approximately 5.5 hours. All right, so hopefully you enjoyed working with exponential equations today.